answer for them is to try to do the work without a scratch paper and without a calculator. I would never tell you to do that any other time except for during the math class. There is space though for you to write stuff down when we do go over it. So highly recommend that you do.
Here are a few highlights for the tonight.
If you have the answer to the question, you just put your thumb up. You don't say it. I will usually wait for a decent amount of thumbs to be up before I call on people. So that doesn't mean you look at it and then decide, oh, it's too hard, I'm just not going to try. The whole time you should be trying in your head. You might even be right. So anyway, here's the problem. Raisins cost $4 a pound, walnuts cost $8 a pound. Diego spent $15 on both ingredients. Decide if each pair of values could be a combination of raisins and walnuts that Diego bought. So here's the first one. Try to do it in your head. 1 pound of raisins, 1.5 pounds of walnuts. Could that be a possible combination that he bought? From up if you can.
I'm sorry, what was the question then? What is March 4th?
Do you think that could be a combination that he bought? Brooklyn, what do you think? I don't know. Okay, and how did you determine that?
Well, one time the raisins was $4, I was doing that 1.5 pounds, I wanted to do $12, and then 12 and 12.
Okay, it's 16, right? And it says he spent $15, and you're right. 1.5 pounds of walnuts would be $12 because it's 8 per pound. So 1 pound is 8. Half of 8 is 4. About 1.5. Combine that. So yeah, that could not be a combination. Did anyone do it a different way? Okay. So then one more. If he, let's see if that's a possible combination. So 2.25 pounds of raisins, 0.75 pounds of walnuts. Could that be a possible combination? Put your thumb up when you think you know. Cohen, yes or no for the second part?
Yes.
And how did you figure that out?
If only 25 pounds of raisins are $9, and then 0.75 pounds of walnuts are $6. That was
And then because it was like without a calculator, how could you make that like easy to do in your head?
take 1.6 out of the 9 and plus 5.
No, not that part.
Oh.
This part. I'm like, wait, what are you talking about? Hold on. Pause. 1 second. The multiplication part, like, as you know, this was 9 without a calculator. Or did you use a calculator?
I didn't use a calculator.
Okay, how'd you know?
It's kind of big.
Okay, can someone explain that? How to do that math easy mentally? Because it is 9. So like, how do you know?
Oh, I put 4 plus 4, and then that's 8, and then 20, or like a quarter of 4 is 1. And just add it.
Okay, perfect. right? 0.25, even 0.75, like think of it as quarters. What's 0.75 of 8? We'll split 8 into fourths, so you get like 4 sets of 2. 0.75 would be like 3/4 of that, so 6. So just kind of helping you with the fluency in the math. Would I ever say you can't use the calculator any other time? No. So please like check your work with the calculator. But that does make sense. All right, so practicing that math fluency, but also the main point of this warm up is to remember that we know it's a solution if it makes the equation true. So we're saying that he bought $15 worth. We know that's not true over here because that amounted to 16. 16 does not equal 15. But then down here, we got 15 when we did the math. That does equal 15, so that's why it was a solution. So questions on the warm up. All right, so using the same situation, the fact that raisins are $4 a pound and walnuts are $8 a pound, we're going to use that to complete this table. So it's still also that he's spending $15 on both ingredients. So in your groups, write an equation to represent that situation. And then let X be for raisins and Y be for walnuts. Then you're going to graph it with your graphing technology and complete the table. So questions on what you're doing? It's on your paper too, so like the first table and where it says ABC, that's what you're doing. While you do that, hopefully the announcements are working. I'll play those. So that kind of gives me even some extra time. But like my first hour only gave 3 minutes. So have faith in you. Yes. Okay, you still want to ask?
Yeah.
Okay, when he comes up. B,
4x plus 8y equals 17.
okay, anyone disagree with that?
No.
If you didn't get the equation, does it make sense now? Okay, well, let's start with the equation first. Most of your tests, when you're being asked to make the equation, since we're in the linear functions unit, it's gonna either be in this format, which do you guys remember what this format is called?
Oh, it's like.
Okay, so it's either gonna be in standard form like this, or the other form that Joshua mentioned, which is what?
Oh, no, it's,
The other form is y equals mx plus b. So there you go. It's gonna be one of those two formats. Giving you some tips here, so feel free to write it down if you want to. When you have a word problem, I think it's easiest to look for the totals. So like, what's the total that he spent? $15, so that is usually a loan on one side of the equal sign. And then on the other side, think about what contributes to the $15. If we're talking about dollar amounts, then I should probably have dollar amounts on the other side. Because is the amount per pound changing? No, so that's why we have a 4 here and an 8 here. But is the amount that he's buying changing? That's why they're variables. That's why they said use X for pounds of raisins, Y for pounds of walnuts. Questions on that? Because on your test, I'm telling you now, on your constructed response, you're gonna have a word problem. You're gonna have to make the equation and graph it and tell what the solution is. So it's gonna be something like this. Anyway, it says graph using graphing technology. So what does that mean? Put it in Desmos. You're welcome to use your own graphing calculator. I may or may not be able to help you, but you could always look it up in YouTube. So whatever model calculator you have. Desmos you'll have on all your quizzes and tests.
not your state testing. And for Desmos, do I have to rearrange it first?
Wow, good.
You don't have to for Desmos. If you were graphing by hand, then yeah, you'd probably have to rearrange it first. You will have to graph by hand on your tests too. We can talk about that a different day. Today, we're focusing on something else, and you'll see. But here's what it looks like graphed. 4x plus 8y equals 15. Questions on that process, how to graph it? Okay. It doesn't read other variables, like if you put R and W, you get like that little error thing, because it doesn't know, like it only supports X and Y equations. So that's why they told you to change it to this. Now, moving on to filling out the table. Table 5, if they bought 0 pounds of raisins, how many pounds of walnuts did they buy? 1.875. If you guys disagree, just tell me as we go. Table 6, what about when there's 0.25 pounds of raisin? Okay, I'll have table 7 stole that one, don't steal another one. Table 6, what about when there's 1.375 pounds of walnuts, how many pounds of raisins? Table 8, if there's 1.25 pounds of walnuts, how many raisins? Yeah. Okay. Table 9, what about this one right here? For walnuts when it's 1.75 pounds of raisins. Okay. Okay, let's pause. Did anyone have like any disagreements? Hayden?
3 and 4.
These two?
Yeah.
Okay, so let's, because I really only, I haven't even actually shown you the strategies. I might have before, but not today. So what's a strategy you could use to solve for the part that's missing? And we'll use those parts as an example. Because on your paper, it says find the answers both algebraically and graphically. So algebraically, how could I solve for my raisins when the walnuts is 1.275? What could I do? How do we get the first two answers? Table 5. How'd you get this first answer? Okay, and what did you look at when you used Desmos?
I looked at the X is 0, and then 1 to the Y. 0 and 12.
Okay, so is that a good strategy? Fast? Yeah, that's something that you could do too. And it makes it especially easy when it happens to be your y-intercept, because Desmos will show you your x and y intercepts really easily. So that is an answer. That's how you can do it graphically. Then for this one, if I wanted to find the second one graphically too, I might have to do this. Hold down on the line until you see that the x is 0.25, which is what was given to you. And then see what that y value is. I have to do this one because it's hard. As soon as I click away, it goes away. But just keep your eye on it. As soon as it's 0.25, then that's gonna be the Y value I need, so I need to actually zoom in a little bit more. All right, you see it? I'm gonna let go and then it's gonna go away. Miss Medina? Okay, all right, bye. Okay, so did we see that? Everyone look at the screen. Is that the same Y value that we said it would be when we filled in our table?
Yes.
So that's how you can do it graphically, even the ones that aren't X and Y intercepts. You just have to click and drag. How can I solve it algebraically? We did it Tuesday when we plugged in for X and Y when they bought none of something. None of the games, none of the rides installed. That's what you could also do. So let's see if this answer is right over here. Algebraically. So what's the equation that we said works for this situation?
Or 1 + 2.
And what are they giving us? The X or the Y?
1.
So I'm gonna plug it in for the Y. We said walnuts is Y. And then we're solving for X. So this is how you do it if you don't know how to use your graphing calculator. I would do 8 times 1.375, which is 11. All right, so I got 11 when I multiplied it, and then you're solving for X, a 2-step equation. What do I get rid of first, the 4 or the 11?
4.
No. So solving equations is also gonna be on your test, and it's gonna be more steps than just 2 steps. So make sure you know the process. Whenever you isolate a variable, start with what's farther from that variable. Would that be the 4 or the 11?
11.
How do I cancel the plus 11? Whatever you do on one side. Okay, I get 4x equals with 15 minus 11. Opposite of multiplying 4. What property is that, by the way? Division, property of equality. And then what's 4 divided by 4? So this should actually be 1 over here. And I'll check that graphically in like the next pause. But whether you use a graph or algebra, as long as you're doing it right, that's what it should be. Make sense? All right, and then Hayden, what did you say you got for this one?
155.
All right. Now those other tables, you can use either strategy right now to figure out the other 2 blanks. I'll give you like 1 more minute to do that while I verify this. But we're looking at when Y is 1.375. Almost there, but it's not going quite. Okay, you see it? Everyone look at it. So yes, it should be 1 when the Y is 1.375. All right, and then we wanted to see when the Y is 1.25. Okay, right there. What's the X supposed to be? 1.25. So whatever gets you the right answer, whether you do it algebraically or graphically, do that right now for the next 2. And then I'll get you started on the other one here shortly. Because there's 2 blanks on the table, but it seemed like we were running into issues. So figure that out real quick. 9. The X is 1.75. What should the Y be? 1. And then when X is 3, what should the Y be? when, oh, sorry, let me go to a different table. Table 1, when X is 3, what should the Y be?
0.3.
And those are both correct. Any questions? We all know how to check our answers. Okay, because now we're gonna do the next part. We're adding a new constraint. I'm gonna change this. Here's a new piece of information. Diego bought 2 pounds of raisins and walnuts combined. You're gonna make an equation to represent that constraint. Let X and Y be what they were before, raisins and walnuts. Graph it and complete the table. Again, if you're having trouble making the equation, try filling out the table first. Sometimes that helps you see what math you need to do so that you can make an equation to solve no matter what you're given. Questions on that? So I'll give you like 3 more minutes, and then if you're confused, no one in your group knows what to do, you need to ask before those 3 minutes end. Just say that if you don't know how to make the equation, maybe start with the table. So whatever you want to start with, I'll start over here at table 3. Either give me the equation or start filling out the table. Okay, so it says they bought a total of 2 pounds of raisins and walnuts combined. So they're saying that if there's 0 pounds of raisins bought, did we buy 2 pounds of walnuts? Yeah, does that meet this constraint? 2 pounds total? Okay, good. Table 4, if they bought 0.25 pounds of raisins, how many pounds of walnuts?
Oh, okay, I'm not thinking right. Wait, why is that one?
Around this one.
1.75.
All right, now switch the reporter 2 to the left. Whoever spoke for your table last, go 2 to the left.
Okay.
All right, so then table 5.
I got my equation.
Then back to you once you figure out the equation. So that'll be your responsibility. All right, simmer down. It shouldn't matter who the reporter is because you all talked about it. At least you were supposed to. So anyway, table 6. When there's 1.375 pounds of walnuts, how many pounds of raisins? We'll figure it out. They have to buy 2 pounds total, and they bought this many of the walnuts. How many of the raisins? But they are supposed to buy 2 pounds total. So if I add these together, does that add to 2? Okay. So we'll come back to you guys for that one. So this one will be your responsibility. Table 7. Can you give me it for this one? 0.75. Table 8, can you give me it for this one where my mouse is? And then table 9, what about this one?
Would it be 0? Okay.
Well, it's supposed to total to 2. So is 3 plus 0, 2?
No.
What plus 3 gives me 2?
-1.
Now, does that really make sense?
No.
No, but that's what it would have to be. So maybe just in parentheses, but like not possible. I can't buy negative pounds of walnuts, but that's what it has to be to total the 2. That's a constraint. Table 6, did we find this value? Okay, he's working on it.
Table 5, did you make the equation?
Yeah,
What is it?
I got 25x plus 1.75y equals.
Okay, but I shouldn't have the 15 in this. Like the 15 was the total spent. Right now, we're just looking at the total pounds. So use those strategies again. Let's do that part as a class then. I bought 2 pounds total. So that means the 2 should be alone on one side of the equal sign. And then what contributes to that total? The pounds of each that you bought. Now, is it staying the same each time? So it's varying each time. I should use. So you should do x plus y. That's the math we were doing, right? This plus this gives me 2. This plus this gives me 2. This plus this gives me 2. That's your equation. And for systems of equations, one of them is probably going to be that easy, just so you know. Not always, but usually. It'll be like x plus y equals something. All right, table 6, we have it. 0.625. Now it's all correct. Any questions? Now to graph it, maybe write some instructions to yourself. How do you graph? With graphing technology. You just type it into Desmos. You don't even have to rearrange it. If you're graphing by hand, yeah, you need to rearrange it to slope-intercept form, but we'll talk about that another day. The goal is actually to understand systems of linear equations and those solutions. So that's why we're focusing more on this graphing with this calculator today. All right, but now you're gonna answer number 3. Listen, we're gonna take both constraints and combine them. So they're spending $15 and buying exactly 2 pounds now. You're gonna decide what the solution has to be. Discuss that with your group, like literally less than a minute. What would the solution have to be if you spent $15 and bought exactly 2 pounds?
Wait,
Harley? Okay, did I hear you correctly? Okay, well, does this add to 2 pounds? It adds to 250. So from that alone, it can't be that one, but try again. Everyone look at your tables. If it has to meet both constraints at the same time, Cohen,
0.25x plus 1.75y.
okay, I think I know what it should be, like 0.25 of the raisins, 1.75 of the walnut. And how did you come to that answer?
If you add it together, it equals 2, which is 2 pounds. Yeah.
What about the $15 part?
The 15, well, 1.75 would be. Would be 20, and then a quarter of 4 would be 1. And what we need is 15 down, 3/4. Right?
Hold on. I think on our first page, there might be a mistake. And that's why. So look at your first table. We made a mistake and I don't think we fixed it. This should be 1.75. But Cohen is right. He did do the math right. What I was hoping you guys would notice, but you couldn't if it was written wrong on the paper, is that if you looked at both tables, they have this coordinate in common. This one gives me that it equals 15. And it gives me that it equals 2 pounds. Sorry. I guess it would help if you had the right thing written down on your paper. So make sure, maybe highlight, star that. Fix this on your first table. It should be 1.75. Right here, everyone see that? But because it meets both constraints at the same time, that is my solution. That's what brings us to our like vocabulary of the day. So this is right. That's my solution to the system because it meets both constraints at the same time. So then maybe in that same area, put down that the solution to a system of equations. So maybe, hold on. A system of equations is 2 or more equations. We're just going to look at 2 in this class. It's going to be 2 or more equations that have the same variables. Just like these ones do. They had both x and y that represented the same thing. So 2 or more equations that have the same variables would be your system of equations. Anywhere like a space. A system of equations would be 2 or more equations that have the same variables. Like the one that we have for our situation. You could write them like this as a system of equations. Usually you'll see that symbol to show that they're a system. Doesn't necessarily have to be there though. They could just tell you it's a system. Which means then that a solution to the system would be values for the variables that make both equations true. So values for the variables that make both equations true. At the same time. All right, so write that really just anywhere that you have room. If you don't think you write fast enough, maybe take a picture so that when I flip the screen, you can still write it for your notes. That's like the whole point of this. We looked at solutions separately for each equation that you saw that there's like infinite amounts for each equation. But when you write them as a system, in this one, there's only one that satisfies both at the same time. And that's why our answer was the 0.25, comma 1.75. That was our solution. And I made both of them true. And I wrote it as a coordinate, x, y. So I'm gonna flip the screen here. There's other types of solutions you could get. This is an example of when there's just one solution, which is that pair. The other types are no solution and infinite solution. So again, just write this really anywhere that you have room. I could tell you we're not doing the very last problem, so if you want to write it there. But these are the types of solutions that you can get for systems of equations. One solution would be where the 2 lines intersect. So if you were to graph both of those lines that we did, then the solution would be the XY value that they intersect at. And then here's other types, but I feel like we don't see them that frequently in our lessons, but you might see them on your test. So that's why you have to know that. It's possible to have no solution. So that means that no X or Y pair makes either of them true, or like both of them true at the same time. So this is what it would look like if you graphed it. What do we call it when 2 lines never intersect? They're parallel lines. Do you know what makes them parallel, other than that they never intersect? They have the same
And.
kind of slope. I mean, if you think of it as like if an angle, slope is an angle. Then yeah, they have the same slope, different y-intercept. That's why they never intersect, because slope is what it changes by each time. They're changing by the same amount each time, but they started at different places, so that's why they're never intersecting. No solutions. Then there's infinite solutions. So if you graph two lines, but it only looks like one line, what happened? Where is the other line? If I graph two lines, and it just looks like one line. They're on top of each other. That's why you can't see it. That's why it only looks like one line. So that would be the same line, because they have the same slope and the same y-intercept of the two different lines that you graph. So it might look different, but then when you graph them both, you see they're actually the same line. You have infinite solutions, because there's literally any pair that's on that line that makes it both true. Question done. So if it's just one solution, you have to tell me what that solution is, the XY value that it intersects at. Any questions? Now we can do one more. Or I could give you time to start your practice, so you actually have to do it. You can't just pack up and then wait for 8 minutes.
Practice.
So, favor of practice? Raise your hand.
Practice.
In favor of doing one more? Okay, well, you could always try the others on your own time and then ask me if they're correct later. But I'm giving you time to do your practice. You need to actually do it and not just sit around and wait. But I'll leave it.